I have to say that I'm positively surprised at the audience, kind of. Sustainability sessions, there's always a bit of a dependency on how many people come, but great to see. Oh, there's even more. Perfect. Welcome in. So, how Kubernetes optimization can combat climate change is the topic today. Kind of broad, very big. We're saving the world here. I think it's really cool. All good. Let's get started. So, I am Annie Talvasto. Nice to meet you all. I am a senior product marketing manager at Camunda, which is a process orchestration company. And I'm also a CNCF ambassador as well as an Azure MVP. I'm also a Kubernetes and CNCF meetup co-organizer, an early stage startup coach, as well as co-host of the Cloud Gossip podcast. So what all of that means that I just spend way too much of my time speaking about containers, Kubernetes, and the cloud in general. So those are my happy places to be at for sure. I also host a weekly live stream for CNCF every Wednesday. And I am frequently in the KubeCon plus Cloud Native Con program committee. So overall Kubernetes person. I speak a lot about Kubernetes topics. Sustainability topics are now a new thing that I'm adding to my repertoire as well. So perfect. Then welcome to the session. So this session and like what will you learn here? So it's essentially, I will have a more detailed agenda in the next slide, but we have essentially the principles of green software, the principles of how to build sustainable software first. And then we have more Kubernetes specific things, so how to use the principles in practice for microservices, and actual open source tooling that you can use even today, tomorrow, whenever you want to take your first steps or your next steps in Kubernetes sustainability in general. And to be honest, since sustainability space is quite fresh and new, it's not the most, oldest space. Obviously, sustainability is old, but in the software context and the focus on it is relatively new. So there's a lot of changes constantly in this space, which means that I think I did the session in Germany a couple weeks ago, and there's already been updates in the space. And I was just checking out the updates, and actually there will be, I know already that there's going to be new, really interesting initiatives launching within the next 1 to 2 months. So when I'm doing this session in NDC London, for example, I will have to redo a lot of the stuff again. So it's really developing a lot. So you can't really have like perfect answers for everything at the moment, because everything is changing, shifting, and really updating quite fast, because we're green software and green Kubernetes and everything. Essentially, the foundations are being built as we speak. So it's very at that level, the development there. So we're going to kick off. This is the introduction that we have going on right now. And then we have principles of green software, then in practice. And then we have some CNCF open projects that you can use, and then an optimization example that you can use as well. And then obviously ending with some resources and a conclusion. Before we start, how many here has heard about the Green Software Foundation? A few people, perfect. Better actually that most people haven't heard, because then you'll actually be learning something new. What I do notice that there's sometimes when I do these sustainability sessions, there's a lot of people who are like really, really deep in sustainability that come to the session, because it is an important one. I love it, welcome. But obviously I'm gonna start from the beginning, so to say, from the introduction stuff, so that everyone can kind of get started there together. So that's the agenda for today. So I think in general, people care a lot about sustainability for a long time now. It's been a major trend across, consumer behavior, for example. But at the same time, I think the kind of, how do people approach sustainability at work? That's a topic that maybe is catching up as we speak right now. It's not as widely used. But nowadays, you can see more and more about it. I love when companies, for example, adopt policies around very either minimal swag or mindful swag in companies like booths and whatnot, for example, rather than, trying to push gazillion t-shirts to everyone. Like if you want a t-shirt, that's obviously amazing. But in a way that actually thinking about these practices and thinking about their impact, I think that's a bit new, and it's really great. And it goes to the software world as well, obviously. So sustainability and software development as a whole. So I think everyone is aware about the impact of airline industry, energy consumption, and all of these kind of things. But people quite often overlook the impact of the technology industry, that it adds actually exactly the same amount of emissions to the world, for example, already in 27, so the same as airline industry. So it is a major contributor to the world as far as things go. And data centers are currently using 2% of the world's energy. So that's 2% sounds small, but it is absolutely huge, obviously. And with the advent of like modern technologies, so everywhere from AI to machine learning to crypto and everything, the need and the emissions are just increasing more and more, and they're predicted to increase even more as we go further. So it's definitely not a thing that will just go away if we ignore it. We really have to think about it because the usage will only increase in the future. And I think maybe everyone here realizes that because you have come to a sustainability session, but really the world is going to see a lot of irreversible changes if climate change remains to be unchecked. So it is a very important topic to kind of focus on as well. So why is the session then called How Kubernetes Optimization Can Combat Climate Change? If this is like a whole technology area, not an issue, but like challenge that we have to face. Well, I think Kubernetes is very much nowadays a big backbone of mainstream global technology. It's become very widely used, particularly at enterprise level and at scale. So all of the biggest emissions and whatnot probably have Kubernetes in the background, for example. So if we can get Kubernetes as well as the software around it to a more green place, I think we'll all benefit. And this is from the latest published CNCF survey, which is a survey that looks into Kubernetes use and container use in general globally. And in here, it had record high numbers. So 96% of organizations are either using or evaluating Kubernetes. So it is very much a household name, and it's very much here to stay. And obviously for a session like this, I have to choose a topic to focus on because already Kubernetes optimization, to be honest, is way too wide of a topic. Like it's impossible to cover Kubernetes optimization in an hour, let alone sustainability and all of these kind of things. Obviously one can try, and we're gonna try today, but still, like, because essentially every configuration best practice that you have around for optimizing anything could be applied to an extent to this topic. So anything that you see, very much. So this is just from the regular Kubernetes doc. So there's a lot that one could do around this space for sure. Yeah, so then we're gonna kick off with the principles of green software. So there was 2 people, I think, who had heard about Green Software Foundation. Have you gone through the principles of green software, or anyone else if they skipped the foundation part but gone straight to the principles? Anyone familiar with them? Perfect, then we're gonna do some learning. I love that, great. Not encouraging anyone. If you know something, please do raise your hand, of course. That's really great as well. Yeah. So the principles of green software are built by the Green Software Foundation, which is, in my opinion, one of the best resources right now for sustainable and green software information. And they are one of the players who are really working on building those foundational pieces. There's other players as well, and there's a new one. I have a mention of that later, but in the Kubernetes space specifically, there's a kickoff of that similar project a bit as well. But it's very, very early on still. It's way earlier than Green Software Foundation. It's been around for a bit already. So it's a nonprofit formed under Linux Foundation. So it is obviously since CNCF is one of those as well, so under Linux Foundation. So what are the principles then? So the main one, the big one kind of, that is, for example, build up carbon usage, so build applications that are carbon efficient. Because obviously the usage of carbon, we have to cut down on that. So if you build applications that are carbon efficient, you're on a good road. The other is electricity, so build applications that are energy efficient. And then I think anyone can start seeing a trend here. You know, there's a thing that's bad, be efficient with it, use it mindfully, and that's the kind of principle there with electricity and carbon. And then we have carbon intensity, which is essentially the measure of how much carbon emissions produced per kilowatt hour of electricity is consumed. So then it goes a bit deeper into this thing, and it actually describes how well are we using these? So consuming electricity with the lowest carbon intensity is important. Then we have embodied carbon, so building applications that are hardware efficient. So embodied carbon is different from carbon because carbon would be the general, for example, it could be the high level of everything, and then embodied carbon would be within that, in that bucket. And it would be, for example, the servers, the data centers, so the actual physical things that are needed to run the software rather than the whole of the sum of the parts in a way. Then we have energy proportionality, and I think proportionality is an incredibly difficult word to say, at least for me. It's good, but it's a nice word. So it's about maximizing the energy efficiency of that said hardware. So you're using your resources really well, so utilization. And networking, so reducing the amount of data and distance it must travel across the network. So the size of the data as well as the distance. And then demand shaping, build carbon-aware applications. I'll go a bit more deeper there in a few. And then measurement and optimization, so focusing on step-by-step optimizations that increase the overall carbon efficiency. Now, I'm going to obviously be going through some optimization tips and measurement tips and tricks here today. But as I mentioned before, it's like an endless amount of things that one could throw through. It's definitely not like kind of like, oh, you do one thing, oh, you're perfect. It's more or less that there's gazillion things that you can do. And I do try to kind of then say that it can get a bit overwhelming. Like if you start thinking about, oh, I have to optimize everything, But then obviously just starting small and with some of the tips and tricks that you can do, that's a good start, obviously. So this is the full list of the principles. But if it's too many things to kind of just like throw at you all of a sudden, you should think about essentially, as mentioned before, focusing on carbon efficiency as the big bucket. And within their energy efficiency and hardware efficiency and carbon awareness are the three that really kind of usually bring a lot of benefits in general. So a bit more about these. So really energy. So I think people don't quite often think about, okay, how clean is energy or dirty? So there's obviously renewable energies, which are clean, and then there's less renewable energies, or like coal and oil and so forth, which is more dirty energy. So these are the places where you have to start. And obviously, if you want to dive super deep into this space, really you have to start recapping okay, what is electricity? What is the measurement of electricity? And really kind of going deeper into there. And then there is a lot of things that you can do around this space as well, because there's a lot of different energy sources that you have available, and it varies globally a lot. So, for example, Nordics have a lot of, in North Europe, for example, have a lot of renewable energy. For example, Norway has a lot of fjords, so you can actually use a lot of renewables there. France, for example, has a lot of nuclear energy. So there's like, it's really, really green in general if you have if you're using electricity, for example, for a data center in France. I've understood that India and Australia have more coal-based, so it differs a lot, but it's locally, there might be a lot of big differences as well. And US is, for example, a bit of a mixed bag. So with energy, one of the big things that you can do is do location shifting. So you can switch between locations that are more or less dirty or clean. And obviously, that's not always possible. I think I've understood that Australia has really strict data protection laws as well, so it's always kind of depends on these things. But if you can, switching them around, and I think Green Software Foundation has this really nifty map as well. It's not really actually actionable, obviously, because it's just a highlight and a kind of snapshot into it, but it does highlight the fact that, okay, you have the slider there into what areas. So even within, for example, US there, if you're using a data center in US, there is a big difference between the different areas and the level that they have dirty and clean energy, because it might vary a lot locally. It particularly varies per coast to coast, because it depends on when the energy infrastructure has been built, what's there around, and obviously, for example, for data centers in the north, you'll need less cooling, so particularly that also helps. So there's a lot of factors that go into it as well. And there's been some work around this. I think Google had a project where they switched around even locally between data centers and seeing like what kind of effects that could have, and they were able to cut at least 1%, I think, of their emissions, which is, again, sounds small, but quite a big impact when you're thinking about the scale of these actions, for sure. Then we have time shifting. So this is from Wikipedia, which is the duck curve. So essentially, unfortunately, the peak hours for electricity usage are actually the hours when, for example, solar energy is not available, because it's usually after it gets dark. So we see these kind of patterns. So shifting around different areas. So when are you doing, for example, different actions? For example, simple batch job, for example, if you can delay it when carbon intensity is lower, even by 1 hour, you will have a major impact. And to be honest, like, does it really matter usually per hour if you're doing something? I think a good example of this is Windows recently has made a change that their updates, for example, they don't go like immediately. They try to look for the spot when you can actually have an energy efficient moment within time. So when the carbon intensity is low, so then you would need to update then. So these kind of things help as well. There's demand shaping as well. So this is from the Branch magazine, and I think I can actually show it quickly. Let's see. So, because I think it works better if I actually show it. Oh, that's bad. There we go. That works better. So this is how the magazine page looks like. And for example, now you just have this. There's no images. But if I click here, it's going to show image, because obviously it's showing images, particularly if the energy is dirty, that's going to take more. And they have the grid intensity view here. So it's live, so it's optimizing there. But then if I click high, then again, the image is not available. But if grid intensity is low, then we're going to have more colors. We're going to have the images immediately. So building these kind of things, because obviously you can't, like, the website will be always there. You can't just, not have it up when the intensity is not optimal. But these kind of things you can obviously do if you have, for example, this kind of website where it's nice to have an image, but is it necessary at all the time? And then you have the middle part, which is moderate, for example, when you have grayscale images there. So there's a lot of things that one can do on that space as well. And then the one that's very, very relevant for Kubernetes particularly is increasing utilization, because as a default, Kubernetes is not really good at using the maximal capacity, so utilization is quite bad usually. So it is essentially the fact that instead of using multiple resources and only using them as in this image, like 30%, for example, actually using the 100%. And obviously it's easier said than done, but going for this, if possible, obviously will have a very positive impact as well. And I mentioned before about all of the different initiatives that are happening in this space. So the Green Software Foundation has a new project that's coming right now. So the release should be in a matter of weeks or so, which is the Software Carbon Intensity Index, which is essentially a method to calculate, okay, you have this application, what's the index? How bad is it? How good is it? The foundation, for example, says that they are in talks with making it an ICO standard in, let's say, half a year or so. So this is the space and the pace of changes happening in this space currently. So there's more and more coming soon. So how does these principles look like then in practice? So taking an example of microservices. So the high-level things that are, for example, recommended by Green Software Foundation would be to optimize your network traffic. And these are the things that you should start with. As mentioned, there's a gazillion things that you can do. Increase your compute utilization, reduce your number of microservices, optimize your database, and understand your latency limitations. So that's the kind of like, okay, if you were to tick, 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 you would be doing good. But again, easier said than done, but kind of looking deeper into there. So what does optimizing your network traffic, for example, actually include? So it means reducing the amount of traffic your architecture creates per operation, as well as the distance each request and response travels. Considering using caching headers, which allow the browser cache and proxy caches to have enough information to confidently cache static assets there. Considering using a CDN to distribute your application's static assets closer to the source of a request, because this reduces the distance all requests for static assets has to travel over the network. And if possible, reducing the size and optimizing your bundles for static assets, and then using compression or decompression for data transmit over your network, because compression and decompression usually takes less overall energy than transmitting uncompressed data over the network. Then what goes into increasing your compute utilization a bit more deeper than just that graphic that I showed before. So updating your workload distribution and compute resources to reduce the amount of energy your compute resources spend in an idle state. Smaller virtual machines to begin with, so rather than big ones that are not utilized very well, actually smaller ones so that they're fit to the need that you have. Then, for example, platforms as service services, quite often they are purpose-built, so they are sized more appropriately for their workloads. So sometimes using those as the default can be already like a good solution. Then using autoscaling to increase and decrease as your demand goes. And I have an autoscaling for Kubernetes with KEDA example coming up, a demo. And then using, so if you have many logical layers in a physical tier, considering increasing your physical tiers and reorganizing where your logical layers run. So it's going to go for more flexible to scale the logical layers independently from there. Then reducing the number of microservices is next. So really actually thinking about the microservices architecture underlying there, because it's already is an effective way to focus the service around a specific business problem and focusing there. So it's important to, and it helps you limit network congestion, latency, and overall complexity. If you can, combining services where the similar scale points exist to reduce the footprint of overall architecture. And if two or more microservices are highly coupled, consider co-locating to reduce network consistency and latency as well. And then use regions with lower carbon intensity. So again, we went kind of through this with the location shifting. And then use languages and technology stacks that optimize the efficiency of specific microservices function. And now this is one that's important, but also it depends a bit. So there's, for example, this study that was done into the energy efficiency across programming languages, which is quite widely spread. I think who here has seen this one actually? Okay, your hands, yes, perfect. Even more than the Green Software Foundation. Usually that's the case. It's a very clickbaity article, to be honest. But obviously, I think also at the same time, keeping in mind that it's not as clear cut as you see there or Rust, and everyone's just gonna now start doing Rust, perfect, because it's also there's other factors that go into it. Because if you write not good, not efficient, not performative Rust, for example, it's probably gonna be worse than doing really well optimized coding, for example, Ruby or something else. So it's not as clear cut that now everyone run in and learn Rust, but preferable maybe if possible. And then in here also I think interesting is the differences there. So the first images, for example, for the energy efficiency of the language, and then second one is for the memory. So Python, for example, is at the bottom of the first one, but then rises up for the other one. So it obviously always depends on your specific case, what's needed and what's not. Then optimizing your database. So first of all, choosing your database well is a good start, because that helps you with energy that you use to run the database, so that you can decrease the idle time waiting for queries to complete. Ensuring that you're using best database for interacting with your data set. And redundant copies are a good solution if there is no easy fix there. And then we have also using an index if your database offers it, and consider evaluating optimizing your queries and using database cache as well. Then we have the last but not the least of these in practice here, because everyone wants just to get to the technical demos. I think that's always the highlight of everything. So understanding your latency limits. So thinking about what you actually need from your application, I think, is also a good start, because I think in general in the technology space, because we have been very spoiled with the advent of cloud computing and everything, of having essentially endless resources, endless scaling. So actually thinking about, okay, do we need this? Like, does it have to be immediate? Sometimes it has to, sometimes maybe not. So thinking about these things from the get-go is a good start. Focusing on your request and response cycle as well is important. And then separating operations outside of the request and response cycle. So for example, if there is a request to send an email that blocks the response until the email is sent, you can instead asynchronously send the email using a worker process and unblock the response. Using worker processes at lower priority than web processes, and consider running work processes in a region with lower carbon intensity. So that's something that we spoke about already, as well as when the carbon intensity is the lowest. So essentially the time shifting aspect that we went through there. So then we have CNCF open source projects to complement Kubernetes. And so how many here has heard about the CNCF Foundation before? Yes, 4 or so, perfect. So CNCF is the Cloud Native Computing Foundation, which is building sustainable ecosystems for cloud native software. So CNCF organizes, for example, KubeCon, Cloud Native Con. It's home to Kubernetes and Prometheus, for example. And it's under Linux Foundation, but the main goal for CNCF is to make sure that all of these open source projects within their wing, in a way, they flourish, they succeed, and that's the major goal there. And if you're then wondering, like, okay, is there anything that I can use? How does the landscape look like? Well, it looks like this. So it's kind of a lot if you're seeing it for the first time. If you're seeing it for the 3rd time, 50th time, 100th time, it's always a lot. One could spend hours just speaking about one portion of this. So it's definitely not something that you have to kind of know by heart. There's not going to be a quiz on this later, obviously. But obviously you can deep dive more into there. So there's areas, for example, for security. So if you need something there, you can deep dive there as well. So there's a lot. And I mentioned before that there's also some action around this. So there's a CNCF working group for environmental sustainability, has been established on May 31st on 2022, so quite recent. And I know that they're gearing up right now for KubeCon coming up to do more work there. So as I said, a lot of things happening in this space. If I were to do this session in a week or so, probably I would have a lot of new other things to speak about. So, and if you want to get involved with their work, they have a Slack channel within the CNCF Slack, and they really kind of talk through things there very nicely. So we have autoscaling with KEDA as next up. As I mentioned before, that was one of the list of the principles to use. So what is KEDA then? So KEDA is a project within CNCF, so it's a incubating project. So it would be in that map if we were to zoom in to one of them. So KEDA is really about the fact that default Kubernetes scaling is not well suited for event-driven applications. So then, because Kubernetes is more for resource-based scaling for CPU and memory. So this is where KEDA helps. So it's event-driven scale controlling that can run inside any Kubernetes cluster. So it can monitor the rate of the events to preemptively act before CPU is even affected. So that's where the magic comes in. And you can install it into new or existing clusters, and it has 30 plus built-in scalers, so you can build your own, and it has support for external scaler, external push metrics, or API as well. And now KEDA is actually going for graduation right now within CNCF. So they are becoming, just like ramping up their maturity level, but it's already used by actually quite a large company, so even right now everyone could start using it as well. So then I have a demo on scaling .NET Core Worker with Azure Service Bus. So this is how the demo application from KEDA looks like. So you have the order portal, order processor, order queue, and so forth. But a simple way to think about this would be, for example, to have it's a web shop where you have a bunch of orders. So let's say it's a Halloween or a back to school web shop that has a lot of people rushing in and they need to make their orders fast. So we need to scale up because we want to meet that demand. So now let's go here to actually do the demo, which is always the fun part. Now let's get started. So first we're going to get some visibility so that we see actually what happens within the demo. So we're going to grab this external IP and we're going to put it here. And we have a KEDA order portal here. Actually, it fits quite perfectly. Oh, well done. It's gorgeous when it fits nicely. So we're going to see the orders peeking in here. Then we're going to get a bit more visibility as well. And we're going to go here and we're going to put kubectl get pods here. So we're going to see the status and how many order processors are already there. And then we're going to take another one, kubectl, get deployments there where we have how many of them are in use at the moment and available there. So status and how many is available there. And now we're going to go and actually kind of go to the demo after we have a lot of visibility here. And it's going to be quite fast, so hold on to your hats for sure. But now it's first going to ask us, it will ask, there we go, let's queue some orders. How many do you want? So let's say we want 100 orders coming in. There we go. A fish for Hannah, shoes, cheese, sausages, pizza, a lot of the orders coming in, rushing in at one point. It's a rush, and then we see the queue really spiking up. There it goes. More orders are coming in, KEDA should be kicking off soon with the scaling because the demand is high. There we go. We have containers are being created. They're container creating running. We are at 4 out of 4 order processors. No new orders are coming in, and we peaked at 100, but now it's going to go down. But we're still at 4 out of 4. Usually goes a bit more up from there. Yes, there we go. We have at 5 out of 8, 8 out of 8. Now we are mostly doing just running rather than pending and container creating more. Let's see, does it go even higher? Sometimes, yes. We go up to 10. And now we're really meeting the queue demand here. So the order queue is going down nicely there. So there we are, 10 out of 10 in use, order queue handled, and we're just simply running things nowadays. And obviously downscaling is very important as well for sustainability, not just auto scaling up. So KEDA will automatically downscale from here as well, but it takes a couple of minutes for it to start that. So we're not going to just sit here and wait for that. So we're going to push on and move on to other things. But we can see in the end, if I show you then quickly, what happened there in the end. But no one wants to just sit here and wait for the counter to start going down. There we go. So that was a KEDA demo there. Then another service that you can use to kind of take your Kubernetes specifically to a better performance and sustainable state. So service meshes are really great as well. So Linkerd, how many here has used Linkerd? Okay, kind of. So you at least heard about. How many has heard about you Linkerd? Okay, a few people, yeah. Actually, I forgot to ask KEDA. How many here has heard about KEDA? Okay, one very enthusiastic. Perfect. Oh, so many. KEDA is really making the rounds. I'm very happy for them. When I started speaking about KEDA a few years ago, it's like no one was raising their hand. So I love it when people are actually knowing it nowadays. So the Linkerd then is the topic now. So we have, it's a service mesh, so it's similar to Istio if you know that one, but a bit of a different fundamental way of thinking about service mesh. So it's ultra-light, ultra-fast, and security-first service mesh. And light obviously is good as well in this context. And the overall goal of Linkerd is to reduce the mental overhead of having a service mesh to begin with. And it provides observability, reliability, and security. So the benefits are that, the portions and benefits are that it has a thriving open source community, so there's a lot of people willing to help and get you started as well. It's very simple, very minimalist design, so no complex APIs or configuration needed. For most applications, Linkerd will just work out of the box. It provides a deep runtime diagnostics, so you can get really good diagnostic tools from including automatic service dependency maps and live traffic samples. It's ultra light and ultra fast, so it's built in Rust. Rust makes a comeback here as well. Linkerd's data plane proxies are incredibly small and blazing fast. And it installs in seconds with zero configuration. And the control plane installs into a single namespace, and services can be there added to the mesh one at a time. And it has those service metrics, so for example, success rate, request volume, and latency. And then I'm missing a slide for the Linkerd demo, but we're not gonna let that bother us. We're just gonna jump right into the demo without the slide. But essentially, I have a really quick demo on how does Linkerd look like, how does it feel to use it, and so forth. And if you are looking to use Linkerd, it's very, very easy to get started and very quick. I would say 15 minutes and you would already be running when working with it. But obviously, depends on your setup, but if you have a new cluster. So then, we're gonna start by going here and showing the, sorry, I need to switch the cluster. Yes. Trying to find something that doesn't exist is never gonna end well for me. So then we're gonna try again. We're gonna do there so we can actually see what does the Linkerd demo application look like. We're gonna actually, where do we have it? There we go, let's open a new browser. There we go. So this is how the application looks like that we will be essentially looking at in the Linkerd dashboard. So it's a application where we can vote. So we can choose, we want to vote for the sunglasses one. Pick another one. We can vote for this one. Pick another one. And if we view the leaderboard, we can see that, that's a bit more than the 2 votes that I just gave. So there's bots voting in the background, so we can actually inspect their work there. And there's inbuilt 401s, 404s here, though. So there's a lot of things that you can use there as well. So that's the application in a very simple term. And then let's actually kick Linkerd dashboard up. There we go. No worries, we're not gonna stay in here for long, so we're actually gonna, let's see, there we go, it's actually gonna pop here. And now we can actually see here as well, because we went here. So here you see terminating. You didn't see me touch this at all. Everything went terminating and 0, 0 here on the KEDA side, so great. Then we can see here, how does the Linkerd look like? So you have a lot of different areas here. We have the top metrics. We have success rate, RPS, latency, and everything. And we can click more info here on the emoji voter so we can see all helpful things. Again, success rates and voting and everything. So everything is looking nice there. So it's really easy to get started and use, and very lean and easy to use and actually look into your performance as well. So that's it for Linkerd. And now policies are also something that's important. For example, if you want to use them to help with your sustainable Kubernetes journey. So there's, for example, a sandbox project called Kubernetes, which is designed for Kubernetes only, and it's policies managed as Kubernetes resources with kubectl, git, and customize. And you can validate, mutate, and generate policies there really easily as Kubernetes resources. And it's really gaining traction, particularly for security space, but policies are policies no matter what you use them for. So if you're looking for something like that, there's this project as well. It's a sandbox one, so it's very early on its journey there as well. Now, one of the things where I've run into is trying to find more sustainable tips and tricks of optimization and everything around this space. It's sometimes difficult to find them. because also the space is quite new. So one of the things that I usually also try to then find, okay, is there any cost optimization examples, cost optimization tooling, for example, that could help one get started? It's not obviously exactly the same as doing sustainable things, but you can kind of use it to get somewhere at least. And in that space, for example, using spot instances or spot VMs can also be a really nice way to get your utilization up and so forth. So here they are. So cloud pricing in general works with there's on-demand instances, their reserved instances, and spot VMs and so forth that I mentioned there. An example of how to use this, for example, is if you look at this list of cost optimization practices. So defining your requirements sounds very similar to the sustainability stuff. So we're thinking about what do you need and why. Choosing right instance types, again, very sustainable practice there. Storage limitations as well goes to the same vein, and then checking if your workload is spot ready, if you want to use them to get your utilization high, cherry picking the instances so that you can actually kind of really choose what you use and think about that, and then put your price on spot and use mixed instances, which is very Kubernetes specific for this area. So it's really great for availability and performance. So you basically pick different instance types, since some are cheaper, or in this case, if you're looking for sustainable part, or so forth, and you might want to use them as a mixed thing as well. So I kind of usually also look into these kind of things if I'm thinking, okay, I need something to get started, and there's not exactly something for that that I'm looking for. And again, make multiple regions work for you. Again, cost optimization, sustainability optimization, there's a lot of things that you can kind of learn from both. And if everyone is incredibly overwhelmed right now with all of the info that we have gone through, I think there's like really easy ways to get. So like think about observability. Before you can actually start optimizing, you really need to know what you're optimizing and why. So really like thinking about that, where, for example, service meshes and these kind of things can help you. Then doing the optimizing and starting with something that's actually usable for your work or organization. And then really focusing on the governance, for example, and building good practices there. So these are the ways to kind of get started if everything is too much in that space. And now, obviously, sustainability as a goal is worthy on its own, and that should not be kind of taken away. But there is usually, like if you do sustainable practices, you usually end up doing a lot of organizational improvements, because if you are actually thinking about, okay, how does our operation run? How do we do it? How do we run this in a really good way? You end up usually having improvements there. Improved performance is usually another factor that goes into there. Cost savings usually happen as well. Sustainability goals as well, obviously. And obviously, in the end, we're saving the world as well, as is this superhero cat there. And I know that sometimes it's a bit of a mixed bag on how do you want to, for example, internally discuss these things. But personally, I don't think there's any harm in mentioning that, oh, there's also probably other benefits around this topic, even though the sustainable portion is the key as well. But yeah, starting to kind of wrap up. So because we have gone through, there's still a lot of resources that I'll share, but we have gone through an introduction, principles of green software, and the principles in practice. So the microservices portion, we went through KEDA, Linkerd, and Kubernetes, and then we went through a bit of optimization, and now it's time for all of those resources. So I'll put all of my slides and materials to my GitHub, so you can find them there. And then I usually get asked about, okay, like what are the cloud vendors, for example, doing in this space? So, well, actually, first, so there's these two from Green Software. So there's Awesome Green Software and Carbon Aware SDK, and particularly the list of Carbon. Okay, now I'm really like. There we are. So Awesome Green Software. So there's a list by Green Software Orientation where we have a lot of content. So there's all of these things around this topic that you can get started. And then, for example, in the cloud-based, because this is something that I get asked usually a lot. So AWS, for example, has a customer carbon footprint tool, Green Cost Explorer as well. Google has materials as well. And for example, if you click here, and you want to start looking into what does it look like for Azure, You will then hop here, and then app for Azure, because that's what we want to use. And then there's, emissions impact dashboard that you can start using, where you're going to get this kind of data out of it. So if you want to start exploring into there, into your cloud usage, that's a good way to get started as well. Now, all of the different vendors use very different language and very different kind of, not very different, but there's differences in how they speak about these things. So they're not exactly comparable 101 usually, but a good place to get started nevertheless. And then there's a Carbon Aware SDK if you're looking more into the carbon awareness side of things, which was released by Green Software Foundation. I wrote an article, a really quick one for the new stack on kind of reducing cloud waste to help save the planet, which is more about the organizational side of things and the benefits that you have there. And Microsoft has an actual Principles of Sustainable Software Engineering course in Learn that you can do as well. That really goes through some of the topics that we went today as well. And I know that the Green Software Foundation is prepping learning content as well that should be released quite soon, I think November or something, the last time I heard. Now there's a lot of different things that you can use from the CNCF space. So we went through KEDA, and if you're really new to Kubernetes, for example, Helm can help with application management, monitoring, Prometheus, container workflow flux, Kubernetes policies. And in addition to Linkerd, there's Kuma and Istio, as well as Mesher, for example, if you're doing multi-mesh management. And then there's a lot of different things from other areas. So, and there's opensustain.tech as well, where there's open technology projects around stable climate, energy supply, and so forth. And Green Software Foundation, like a big shout out to them, obviously. And I think as a conclusion, the big thing I think is that any activity that you can do to optimize performance and really kind of focus on think about it and then optimize, you're going to be on the right path. So if it feels too much, start small, start from somewhere and follow from there. So that's how we're going to end up all being this amazing superhero cat. And we're going to be great on sustainable terms. So thank you everyone for listening, and I'll be here if you have any questions. Very happy to talk to you about them as well. Thank you so much.